Okay, this is 4.6 notes, solving quadratic inequalities. So before we look at the examples, we are first going to read the steps. So step 1 says replace the inequality with an equal sign. Step 2 says solve like normal, whichever solving method you prefer, whether that's the quadratic formula, factoring, or the square root method. Then we're going to graph the boundary points on a number line. We're then going to determine the shading for the solution set by choosing a test point in each section, plugging it into the inequality, and if we get true, we're going to shade with the test point. If false, we do not shade that section. And then lastly, we're going to write our answer using the inequality symbols to establish the solution for the quadratic inequality. Okay. So example 1 is right here. Okay. Our first step is to replace the inequality with an equal sign. So I have 2x minus 3, x plus 6 is equal to 0. Well, this is already factored for us, so we are going to set each of them separately equal to 0 and solve. So we have 2x minus 3 equals 0, x plus 6 equals 0. So this gives us x is equal to 3 halves because we add the 3 over and divide by 2. And this one gives us x is equal to negative 6 because we subtract the 6 over. Okay. Just so we know, 3 halves is the same as saying 1.5. Okay, so we're going to graph these on a number line. We have negative 6, and then we have 1.5. We have to pick test points in each of these 3 sections to test our original inequality. Okay. So we're going to pick a number smaller than negative 6. So I'm going to pick negative 10. We're going to pick a number between negative 6 and 1.5. So I'm going to pick 0. And then a number greater than 1.5, and I'm going to pick 5. Okay. Then we're going to plug in each of these test numbers into our original function. Okay. So I chose 0 and 5. Oops. I'm gonna color code them so you guys can see me plugging in each one. So here's 0, here's 5. So starting with the negative 10, okay, I have 2 times negative 10 minus 3 times negative 10 plus 6 is less than or equal to 0. Well, 2 times negative 10 is negative 20. Negative 20 minus 3 is negative 23. And then negative 10 plus 6 is negative 4 is less than 0. Okay. We don't even have to continue solving this because we have a negative times a negative, which means it's a positive. And a positive number is going to be greater than 0, not less than or equal to 0. So this is a false statement, which means we don't shade. Okay. Now we're going to try 0. So I have 2 times 0 minus 3 times 0 plus 6 is less than or equal to 0. So 2 times 0 is 0. 0 minus 3 is negative 3. 0 plus 6 is 6. Less than or equal to 0. So this is negative 18 is less than or equal to 0, which is a true statement. So we're going to shade. Okay. So that means this section here is a true statement. Okay, then we're going to test our last one, which is 5. So I have 2 times 5 minus 3 times 5 plus 6 is less than or equal to 0. 2 times 5 is 10. 10 minus 3 is 7. So I have 7. 5 plus 6 is 11. Less than or equal to 0. So this is 77 is less than or equal to 0, which is false, which means we don't shade. So that means my answer here is only true between the numbers -6 and 1.5, okay? And since my inequality includes an equal sign up here, I know that I can use those same ones when writing my answer, okay? So I am going to say that the answer is -6 is less than or equal to x, which is less than or equal to 1.5. That's my answer. Okay. So on example 1, it was already factored for us. It gave us our quadratic equation already in intercept form. Example 2 doesn't give it to us in intercept form. We're going to have to do that ourselves. Okay, so our first step is to replace the inequality with an equal sign. So I have 2x squared plus 3x is equal to 2. Okay. I'm going to subtract the 2 over. So I have 2x squared plus 3x minus 2 equals 0. And then I'm going to choose to use the factoring method. You can choose to use the quadratic formula if you think that is easier. So I have my a times c, which is -4, and then my b value, which is 3. So I need two numbers that multiply to -4 but add to 3. So that's going to be 4 times -1. And I can check it on the other side by doing 4 plus -1, which gives me 3. Splitting my b value, I get 2x squared plus 4x minus x minus 2 equals 0. And then I'm going to group the first and then last two terms and take out the GCF from each. So I can take out a 2x and I'm left with x plus 2. And here I can take out a -1 and I'm left with x plus 2 equals 0. So I have 2x minus 1 and x plus 2 equals 0. Then I set them separately equal to 0. So I have 2x minus 1 equals 0 and x plus 2 equals 0, which means I have x is equal to 1/2 and x is equal to -2. Okay. I'm going to plot these on a number line. Okay, so I have -2 and I have 1/2. And then I have to pick my test numbers that are between each section. Okay, so a number smaller than -2, let's choose -4. A number between -2 and 1/2, let's choose 0. And then a number greater than 1/2, let's choose 1. And these test numbers can be any numbers you want as long as they're within those domains of each section. Okay, so starting with -4, we're going to plug it back into our original equation. So I have 2 times -4 squared plus 3 times -4 is greater than 2. So I have to see if I get a true or false statement. So -4 squared is 16, so I have 2 times 16. And then 3 times -4 is -12 is greater than 2. 2 times 16 is 32. 32 minus 12 greater than 2 gives me 20 greater than 2. This is true, so I'm going to shade this section here. Okay, now I'm using my test number of 0. So I have 2 times 0 squared plus 3 times 0 is greater than 2. 0 squared is 0. 2 times 0 is 0, so I have 0. 3 times 0 is 0 plus 0 is greater than 2. 0 is greater than 2. This is false, which means I don't shade. And then my last test number is 1, so I have 2 times 1 squared plus 3 times 1 is greater than 2. So I have 2 times 1 plus 3 is greater than 2. 2 plus 3 is greater than 2. 5 is greater than 2. This is a true statement, so I'm going to shade on this side. Okay. So here, instead of having my solution between the two numbers, It's going in either direction of the two numbers. So this tells me that my answer x is going to be less than -2, or x is going to be greater than 1/2. Okay, so I didn't put less than or equal to or greater than or equal to because my original inequality was just a greater than sign. So this is my answer for this one. Okay, and that becomes true looking at that shaded region above. Okay. Example 3 says determine the values of x that make the inequality true. So our first step is to make this an equal sign. So I have x squared minus 3x equals 0. I can take the GCF of x out and I get x minus 3 equals 0, which means I have x is equal to 0 and x is equal to 3. So drawing my number line, I have 0, I have 3, and I have to pick my 3 test numbers between each section. So I can pick a -1, a 1, and a 5. And remember, these numbers are truly up to you. So I have 0 is less than -1 squared minus 3 times -1. So 0 is less than 1 plus 3. 0 is less than 4, which is true. So I'm going to shade this part. And then I have 0 is less than 1 squared minus 3 times 1. Go see who's at the door. So I have 0 is less than 1 minus 3. 0 is less than -2. This is a false statement, so I'm not going to shade. And then lastly, I'm going to test number 5. And number 5, I do 0 is less than 5 squared minus 3 times 5. So I have 0 is less than 25 minus 15. 0 is less than 10. This is a true statement, so I'm going to shade. Okay. And my original inequality is just a less than sign. So I have x is less than 0 or x is greater than 3, and that is my answer. Okay, last example here. Remember, my first step is to turn it into an equal sign. So I have -3x squared minus 4x minus 1 is equal to 0. Then I'm going to see if this can be factored by doing the a times c method. So a times c is equal to -3 times -1, which is 3. And I need to find numbers that will add to -4. Okay, so that's -1 times -3 or -1 plus -3. So then I have -3x squared minus x minus 3x minus 1 equals 0. I'm going to group my first two and last two terms. So I can take out a negative x, and I'm left with 3x plus 1. And I can take out a -1, and I'm left with 3x plus 1. So I have -x minus 1 and 3x plus 1 is equal to 0. So I have -x minus 1 equals 0, which means I have -x is equal to 1, so x is equal to -1. And then I have 3x plus 1 equals 0, which means x is equal to -1/3. Okay, then put this on a number line. So I have -1 and -1/3, and I have to choose test numbers between each one. So a number smaller than -1 would be -2. A number between -1 and -1/3 would be, so this is like 0.33. So let's do 0.5. So let's do -1/2. And then a number larger than -1/3 would be 0. So I'm going to test each of these numbers. So I have negative 3 times negative 2 squared minus 4 times negative 2 minus 1 is less than or equal to 0. Negative 3 times 4 plus 8 minus 1 is less than or equal to 0. Negative 12 plus 8 minus 1 less than or equal to 0. So this gives me negative 4 minus 1 less than or equal to 0, which is negative 5 less than or equal to 0, which is true. So I would shade this section. Then I got to try negative 1/2. Okay. So I have negative 3 times negative 1/2 squared minus 4 times negative 1/2 minus 1 is less than or equal to 0. So I have negative 3 times 1/4 plus 2 minus 1 is less than or equal to 0. So negative 3/4 plus 2 minus 1 is less than or equal to 0. So that's negative 7/4 plus 8/4 is less than or equal to 0. So we have 1/4 less than or equal to 0, which is false. And then we have 0. So this is negative 3 times 0 squared minus 4 times 0 minus 1 less than or equal to 0. So this is 0 minus 1 less than or equal to 0. Negative 1 less than or equal to 0, which is true. So I would shade the other side. So since my inequality is less than or equal to, I have that my answer is going to be x is less than or equal to negative 1, or x is greater than or equal to negative 1/3.